All right, here we go. Next four questions. If you forgot how to go about solving these rational inequalities, and you want to refresh check the first video where I talked about the theory behind both. But I'm also gonna just walk you through it as we go along here. So, starting number eight. So to me, I think when you're solving a rational inequality, easiest is to not even bother graphing and just check the points where the numerator or denominator are zero, and then just solve analytically from there. So here's what I mean. Okay, what are the things that makes this either 0 or undefined? And the answer would be here, x equal to positive 1 or x equal to negative 2, right? I should just copy this down here again. Oops. Copied it wrong. Just to make it a little easier to see. So x equal to 1 would make that 0, and x equal to negative 2 would make it undefined, right? So that means those are important points to check. Those are critical points to check. Negative 2 and positive 1. And then after that, we just want to know whether we're positive or negative in between. Because those are where their potential changes might happen, right? So something like, and this is what I was saying before, let's keep the zeros or undefined points on the bottom, and the test points will be on the top. So negative 3 is the test point. Between negative 2 and 1 is 0, and then 2 would be to the right. So those are my three test points. I just want to know positive or negative. Okay, so let's look at, let me do this. Get rid of that. Okay, let's check that first test point, negative 3. If I put in negative 3, this top part, negative 3 minus 1, that's going to be negative, right? Negative 3 plus 2 over there in the bottom, also negative. That means negative over negative overall. This first region is going to be positive. And that's going to be true for everywhere to the left of that 0 or undefined point, in this case undefined point, up until you hit that point, right? Okay, what about the next one? What about at 0? 0 is the next point. 0 minus 1 is going to be negative. 0 plus 2 is going to be positive. So overall, negative divided by positive is negative in that region. Okay, and then next test point is 2. 2 minus 1 is going to be positive. 2 plus 2 is positive. So overall, this is going to be positive in that region. Now, what was my original question? Where is it greater than 0, strictly greater than 0? So that means I'm not going to include any of these points. Well, this one was undefined anyway. Maybe it's worth noting what it was. That's undefined. And this was 0. Okay, so it's greater than 0 to the left and to the right, right? So here's the answer then. This area and that area is where it's greater than 0. We're not including the points. So negative infinity up until negative 2. And here we're looking at the bottom numbers, right? Union with, what is that? That's 1. This is a 1, right? And onwards. Okay, I just realized this notation is a little bit confusing because it looks like 0 is the point. So let's write the word out instead. That is a 0. If I plug in 1 into my equation, then I get 0. Not equation, my inequality. Okay, next one. Yeah, I think we'll approach all of them kind of similarly. You don't have to bother to graph. If you really wanted to graph, you could. Use the methods that we learned in I think it was a previous class that we did rational expressions, right? Here's number 9. X minus 3 over x plus 2 greater than or equal to 0. I guess we should graph at least one of these as just practice. But okay, here, what are the zeros? X equal to 0 would be a 0. X equal to 3 would be another 0. X equal to negative 2 would be an undefined point. So those are the important points to check. Negative 2, 0, and positive 3. I think I changed my color scheme. Yeah, sorry. Let's do the zeros back in black. 0 and back in black. Zeros and undefined points. 0 and 3. So what are those? This is undefined point. This is a 0. And 3 is a 0. 0. That looks like 0. 0. Okay. So test points. Something to the left of negative 2, negative 3. Something between them, negative 1. Something between those, positive 1. something above 3, 4. Okay, starting with negative 3. If I plug in negative 3 here, this will be negative. Negative 3 minus 3, negative. And the bottom, negative 3 plus 1, negative. So negative, negative, negative. That's 3 negatives. Overall gives me a negative. Okay, next point. It's negative 1. This will be negative. Negative 1 minus 3, negative. Negative 1 plus 2 is positive. Negative, negative, positive. That's an even number of negatives, so that's positive. Okay, what about positive 1? This will be positive. 1 minus 3, negative. 1 plus 2 is positive. So positive, negative, positive is negative overall. Okay, and then last one, positive 4. This will be positive. 4 minus 3, positive. 4 plus 2, positive. All positive. So that's positive there. Okay, ready to answer the question. So where is it bigger than or equal to 0? This time bigger than or equal to 0. So that would include as well these points, right? These zeros would be included. Let's highlight it. So where is it bigger than or equal to 0? So the positive area here, positive area there, and onwards. And also, let's just keep that, including those boundaries points. Wait. I'm sorry. That's not totally true. Because this one over here, the negative 2, this one was undefined, right? So that one should not be included, sorry. Because that's the rational expression not even defined there. So, okay, ready to answer. Where are we positive, bigger than or equal to 0? No, I should say non-negative more specifically. Negative 2, but not including the negative 2. Up until 0, but this time I include the 0. This one's undefined. This one is a 0. And then also from the point 3, this time including 3, onwards towards infinity, right? So that's the answer. Okay, that is number 9. Let's cross these guys out. 8, 9 done. Great. 2 more. Oh, no. Made a mistake. Oh, no. Oh. Okay. Okay, sorry. Sorry, too slow. Okay, number 10. Okay. Okay, nice and factored for us. That's good news. So number 10, let's write it out. X plus 1 squared, x minus 1 on the top, x plus 4, x minus 3. Okay. Maybe we should graph one. Yeah, we should graph one. Okay, let's do zeros first. Zeros, x equal to negative 1 or positive 1. And then undefined points, x equal to negative 4, x equal to positive 3. Okay, so I've got 2 vertical asymptotes, it looks like. Yeah. So let's graph this one. You should do some practice graphing. And you can double check your work by checking the analytical results too. Okay, I've got vertical asymptotes at negative 4. 1, 2, 3, 4. And positive 3. 1, 2, 3. You know what though, guys? I'm going to end up kind of doing the analytical approach along the way anyway. So I kind of feel like unless the question asks you to graph, which you should be able to graph, at some point you're going to be asked to graph at least one of these rational expressions. But unless that happens, then you don't really need to bother with a graph. You could solve all these inequalities with just the analytical approach. Okay, here I have a horizontal asymptote, and that's going to be the quotient of the leading expressions. Here, notice these are all x's, right? Oh wait, I take it back. There's no horizontal asymptote because the degree in the top is going to be 3. Degree in the bottom is only 2. So there's no horizontal asymptote here. Okay, I do want to know what my zeros were, though, again. So the zeros were at negative 1, which is right there, right? And at positive 1, so right there. Okay. So probably thinking something like, I don't know. There's no. Oh, okay, okay. I see, I see. No horizontal asymptote, but there is an asymptote, oblique asymptote. Top degree power is 1 greater than the bottom, right? So, oh, okay. I chose a kind of difficult one to graph. And you know what? I'm thinking maybe I won't, because I'm feeling lazy. I'll graph number 11 instead, okay? Because I don't want to bother with the oblique asymptote. I think on the top of my head, it's probably gonna look something like this, or maybe slope should probably be 1. I'm not sure off the top of my head if it's gonna. I'm trying to think if it's gonna. I don't know where it's gonna cross off the top of my head. It might be above the origin, so probably something like, I'm guessing like this, and something like this, something like that is the shape. But I don't know for sure. Okay, actually no, it can't be like that because I already plotted the 2 zeros, so it can't cross twice like that. So anyways, long story short, guys, I don't want to bother graphing this. I'm just gonna go straight to the analytical approach instead. It's easier. I'm gonna check here -4. Yeah, okay, so if I wanted to, graph this thing, and how do I do that? I just multiply this thing out, multiply that thing on the bottom, and then I have to do the long division to find the oblique asymptote, and then that will give me a better picture of where it's gonna go. But I'd rather not, so I'm not. And then, okay, let me just plot these things: -1, +1, and +3. Those are either zeros or asymptotes, right? And we're gonna identify what's what. So this is undefined here. 3 is also undefined, right? Okay, -1 was a 0, and +1 also was a 0. 0. Okay, so that means I should check points left and right. So looks like -5, obvious choice. Maybe a -2 over there. Zeros right in between. +2 and +4. And all I care about is whether it's positive or negative at each of those spots. So starting with -5. If I plug in -5 here, doesn't matter what happens because this is squared. So that's always going to be positive. In fact, that's positive every single time. -5 here is negative. -5 there, negative. -5 there, negative. So 3 negatives makes it a negative overall. Okay, on to -2. I'm going to leave that positive in that first spot because, like I said, squared, it's always going to be positive. Here, -2 -1, negative. -2 plus 4, positive. -2 minus 3, negative. 2 negatives makes it a positive. Okay. All right. And then, okay, at 0. 0 plus 1 squared, positive. 0 minus 1, negative. 0 plus 4, positive. 0 minus 3, negative. 2 negatives makes it a positive. Okay, at 2. At 2. 2 minus 1, positive. 2 plus 4, positive. 2 minus 3, negative. So overall, negative. Okay, and then at 4. 4 minus 1, positive. 4 plus 4, positive. 4 minus 3, positive. So overall, positive. Okay, so I could already answer my question here. I want to know when it's less than 0, right? So less than 0 would be here. Oops. Not including the boundary points ever. And over here. I said I wasn't going to sketch it, but I know where it's positive, negative. Let's just kind of try to figure out a sketch. So I have an oblique asymptote somewhere, which means my general shape should be something like this. I know that's negative over there. -2 here is positive here, and then it should be negative here, right? Oh, wait, where is it? 0. 0 is positive as well. And a negative. So what does that mean? Oh, actually, I also know that the -1 is double root. So it looks like this. Stays positive, and then it goes down like that. Yeah. And then over here should be positive. So something like this, following some kind of a oblique asymptote. So yeah, I kind of got a sketch along the way, actually. And I wanted to know when it was negative, right? So that was all this area, and then all this area. Okay. Okay, so here's the answer. I'm looking at negative infinity up until negative 4, not including negative 4. And from, what is it? 1 until 3. Notice, guys, I'm looking at the bottom to figure out these points, right? From 1 to 3. From negative 4, negative 4 to the left, right? And then from 1 to 3, that region there. And not including any of the points because this is a strictly less than 0. Okay. One more to go in this video, and for the first section of rational inequalities. First section meaning, I'm breaking the set of rational inequalities into 2 sets or sections, one might say, like I just have. Okay, this is number 11. 11. I've got 5x minus 9 over x minus 4. It's greater than 4. Oh, okay, so for the first time we see something that's not 0. And that makes us sad. We don't want it to be anything but 0. So how do we do it? Subtract 4 on both sides, right? And if I subtract 4 on both sides, I get 5x minus 9 over x minus 4. Minus 4 is greater than 0. But this doesn't look like a rational expression. So how do I change to rational expression? Well, just change this to common denominators, right? What's 4 in terms of something over x minus 4? Well, let's multiply top and bottom by x minus 4. It's going to be, let me do this step by step here. 5x minus 9 over x minus 4 minus, and then this is 4 over 1 times x minus 4 over x minus 4, right? Okay, let's kind of simplify things here. Let's alternate colors so I keep the rows straight. 5x minus 9 over x minus 4. You can distribute this 4, so that's going to be 4x minus 16 on the top over x minus 4. And now they have same denominators, so I can actually go ahead and subtract. So it's going to be 5x minus 9 minus, and here's big recommendation, keep that in parentheses so you don't mess up the signs. And that's all over the same denominator, right? X minus 4. Remember how we subtract fractions? If not, then this is how we're doing it. This is how we do it. Okay, now 5x minus 4x, right? That's the subtraction. There's just x. Here I've got minus 9 minus negative 16, which is really 9 plus 16. Negative 9 plus 16, which is negative 7. Yeah? Is that right? Negative 9 plus 16 is negative 7. Positive 7. What am I thinking? Yeah. Positive 16 minus 9 is 7. Yes. Okay, over x minus 4. Okay. So that whole thing turned out to be just x plus 7 over x minus 4. And that's all greater than or equal to 0. That's what I want, right? Okay, cool. This looks like a graphable one. Easy graph. Here, x equal to negative 7 is 0. X equal to 4 is an asymptote, undefined there. So let's graph that. Here's x, here's y. Negative 1, 2, 3, 4, 5, 6, 7 is a 0. And x equal to 1, 2, 3, 4 is an asymptote. So my asymptote looks like this. X equals to positive 4. This is basically 1 over x type, but shifted somewhere. I have a horizontal asymptote here at the result of dividing the leading coefficients, which is just 1. So horizontal asymptote here at y equal to 1. Yeah. Something like this. Okay, I know I'm on the bottom over there, which means as I'm going to push the asymptote to the left, right? So it should be something like this. It's going to cross there, right? And then it's going to approach that asymptote there. And then it's going to continue onwards in that direction. You know, not a little nicer than that, but you get the idea. And this part, it's going to be over here. right? Above the horizontal asymptote. So, okay, so now answering the question, where is it going to be bigger than 0? Or it's going to be bigger than 0 to the left of that point there, which is -7. And then forever after +4. Yeah, you can confirm that analytically if you want, but I said I already have the answer, and I was allowing myself to choose either method, so let's just do this method. So that's negative infinity up until I hit -7 here. This is -7. This is 4. And then unioned with 4 onwards, and not including the endpoints because, again, this is strictly graded. So I don't include this -7 where it's equal. I wouldn't include the +4 in any case because that's an undefined point. That's an asymptote. So there it is. That's the answer. Okay, guys. See ya in the next one.